Okay, so I'm going over homework questions from Unit 7, Packet 1, and you guys requested number 6 from 1 through 12. So we multiply 2 times 3. What's 2 times 3? Square root, and then we multiply 15 and 20 just to see if it's a perfect squared. What's 15 times 20? Now, it's not a perfect square, but what numbers should I use? Instead of breaking up to 15 and 20, what should I use? 3 and... Why? Because 100 can be broken up into what? Not 25 and 25. You're thinking 25 and 4, but even better than that, 10 and 10. Why would I use, if I could use other numbers, why would I use 10 and 10? Because it's a pair. It's not prime, but it's a pair. 3, 10, 10. And we talked about our shortcuts last week. Do you have to break 10 and 10 down further? No. You can. Do you have to? No, because it's a pair. This comes out as what? And I do what with the 10 that comes out and the 6 that's already there? And 6 times 10 is root, what stays in? 3. Did anybody get that? 60 root 3? Good job. Where did the 60 come from? Can anybody answer his question?
Oh, 6 times 10. Why would you multiply 6 times?
Because this is saying 6 times whatever comes out of 3, 10, 10, and you're telling me the 10 comes out, right? So it's 6 times 10 comes in, and when you multiply that 6 is not in a radical, 10 is not in a radical, so those are the numbers that get multiplied. And 6 times 10 is 60 root 3. So you're saying right here 6 times whatever comes out, and the 10 comes out, so 6 times 10 is 60. Got it? Any others from the 1 through 12? No? Number 3. Okay, so this has a number on the outside that will have to get broken down as well. Anybody tell me what you did for 32? What numbers? 16 and 2. Good job. Did anybody use 4 and 8? Is that okay? Yes. Why do you think he said 16 and 2? Because 16, go ahead. Because this is 4 and 4. Is it prime? No, but are they pairs? Okay, so 7 times 2, 4, and 4. What's coming out? What pair is coming out? Does it come out as 4 or 16? 4. Now, John, what do we do with the 4 and the 7? And anybody do that for us? What is 4 times 7? 28 root. What stays in? 2. Got it? Yes? All right. Questions on 13, 14, 15, or 16? 13 through 16. No questions? You guys have got those okay? No questions? Let's at least set 2 of them up. I'm going to ask Sartaj to help me set up number 15. Just tell me how to set it up. Like what squared plus what squared equals what squared? 4 squared equals 6 squared? It's a squared plus b squared equals c squared. So 4 squared plus what?
6 squared
equals c squared. Good. All right, let's set up number 15. I'm going to call on Faith. Faith, can you tell me how to set this one up?
Square root of 5 squared plus the square root of 7 squared equals c squared.
Good job. Can anybody tell us what the square root of 5 squared is? 5. What's the square root of 7 squared? 7. All right, I do want to set up one more. I'm going to call on Jackson. Jackson, can you tell me how to set up number 14?
A squared plus 3 squared equals 15 squared.
Root 15 squared? Good job. There was no a, so that's his a squared, and then b is 3, so 3 squared equals a square root of 15 squared. All right, you guys have got the handle on this, yes? Might as well set up the last one since we've done this many already. Serenity, can you give it to me, please?
5 squared plus 6 squared.
Good job. All right, number 17 through 18. Any questions on any one of those? 17 or 18? No questions? Shall we do 18 then?
Yeah.
Okay. I will call on James. James, tell me how to set this one up. What squared plus what squared equals what squared?
14 squared plus 7 squared equals c squared. X
Okay, do you guys agree with him? Now, you said 14 squared plus 7 squared, but it's root 14 and root 7. Do you guys agree? Yes? Okay. Thank you. Audrey, can you set this one up for us?
3 squared plus x squared equals 14. 14 squared.
Thank you. So, is our variable always the c? Oh, excuse me. Thank you. All right, so the question, is x always going to be the c squared? No, x over here is the b squared, so it just depends on where the variable is located. Does anybody need help working these out, or you guys are good? One of them? None of them? One? Pick one. 17? Okay, what's the square root of 14 squared? What's the square root of 7 squared? And x squared is x squared. What's 14 plus 7? And then you guys learned last year, what do you do to both sides to solve? And you do that because the square root is the inverse function of x squared, so they undo each other, leaving you with the x equals root 21. What does 21 break down into? Do any pairs come out? No, 7's prime, 3 is prime, so x equals root 21 is your final answer. Make sense? Okay, let's move over to the back side. Questions on 21 through 24. State if each triangle is a right triangle. What test did you have to do on these four? What did you have to test it with? What is this called? Pythagorean's theorem. You test it with Pythagorean's theorem to check. If it works, it is a right triangle. If it does not work, it's not a right triangle. Does anyone want to see one of those worked out? Number 21. All right. So what is going to be the C in this picture? This right here is your C. Okay. So you have a squared, which is 4 squared, plus b squared, which would be 14 squared, equals c squared, which is 2 root 53 squared. Okay. What's 4 squared? Plus, what's 14 squared? 196? What was that? Okay, now who remembers, I've shown you guys, at least maybe I thought I did, I may not have, shown you different ways of doing this. If I did not, can anybody tell me which way I have shown you how to work this one out? Okay, so it's 2 times 2 and root 53 times root 53. Can I write it like that? Is that okay? Yep. What's 2 times 2? Without knowing what 53 times 53 is, what is the square root of 53 times the square root of 53? 53. Okay, and what's 16 plus 196? Can anybody work that out? 16 plus 196. Did I hear it? 212. And then you do 4 times 53. Has anybody done that yet? 4 times 53. What is it? 212 is correct. Do they come out to be equal to each other? Yes. So what would your answer be? Right triangle or not a right triangle? Okay. Now say you got 212 equals 210. Then your answer would be no, not a right triangle. Make sense? All right, questions on this? Was the only really new stuff you had on this lesson. Everything else was review from either this year or last year. Any questions on these here? Shall we do 1 or 2 of these together? Can you guys pick 1 or 2? 27 is a good one. Which one? 30. Okay. Starting off with this one, it's up to you if you want to reduce first or not. Do you want to reduce? It's probably better. Do you guys want to reduce the 4 and the 6? Because we can. They're not in radicals. They are both even. What goes into 4 that also goes into 6? 2. So what's 6 divided by 2? And what's 4 divided by 2? And then the root 2 stays root 2. Does everybody see that? Okay, we didn't see one like this in notes, but we do the exact same thing we did in notes. We multiply top and bottom only by the radical, because you agree this is the only part that's not allowed in the denominator, right? This 2 is okay, that 3 is okay. It's the radical 2 in the denominator that's not allowed. So what do I multiply top and bottom by? Root 2 is correct. You could do 2 root 2. It's just going to make more reducing at the end. Okay, why root 2 over root 2? Because root 2 over root 2 is equivalent to 1, and 1 is the multiplicative identity, property. You are correct. And of all the radicals in the world, why radical 2 and not, say, root 5? Because I want these two here to be a pair. All right, so let's work with the bottom first. This 2 out here is going to stay there. There's nothing going on with that 2. And then we have this piece right here. What is root 2 times root 2? 2. Now the top, can I multiply these together and get 6? No, how do I write it? 3 root 2. So I have 3 root 2 divided by what? Divided by 4. And nothing reduces. The 3 and the 4 don't reduce. I can't reduce these two because this is a radical and this is not. So that is your final answer. Would you guys rather me, are you guys okay if I do 28 as well? Okay. So can we reduce the 3 and the 6? Yes or no? What goes into 6? It also goes into 3. What's 6 divided? You know what? I'd rather do 26. Do all of them? I will do 26 as well then. Okay, so I'm sorry. 6 divided by 3 is? And 3 divided by 3? 1. Do I have to write the 1 or can I just put root 7? Is it okay if you put 1 root 7? Yes. Do you have to? No. What do I multiply top and bottom by? The root 7. And 2 times root 7 is exactly that. 2 root 7. You cannot multiply them together to get a root 14. Now what's root 7 times root 7 because it is a pair? 7. Ask me a question. Specific question, not just what. Well, let's try one more. Let's try another one. Okay. Does 5 and 2 reduce? No. So, the only thing I need to get rid of is the radical. So, not 2 root 6, but what do I multiply by? Just the root 6. Again, not 2 root 6, just root 6. It's okay if you do 2 root 6, you just have more reducing at the end. What is 5 times root 6? 5 root 6. Yes, question? Why root 6 over root 6? Oh, this right here? Like we did over here? Why? Can anybody answer that? Why didn't we simplify first? They're both numbers, nothing goes in. Because nothing reduces to 2 and 5. Do you see? If it was 2 and 10 or 5 and 10,
So if nothing reduces until you gonna do it.
right. You only reduce if something reduces into both the coefficients. Okay? Or both the radicals. Like right here you can reduce these two because they're both radicals. What is root 6 divided by root 3? And do you have any more work to do after that? No, because there's no radical where? In the denominator. So this one's done. I did an extra one for you guys. Root 6 divided by root 3 is root 2. No more simplifying needed because there's no radical in the denominator. Let's go back to number 26. The 2 in the front is going to stay there. And what I'm multiplying right now, which is what I'm trying to do, is the root 6 times root 6. This is the whole reason we're doing this problem. What is root 6 times root 6? 6. So the whole reason we do this is to get rid of the radical in the denominator. Did we accomplish that? Yes, we got rid of the radical because root 6 times root 6 is just 6. So what am I left with? 5 root 6 over 12. Now, these two guys are the only guys you're allowed to reduce. But does anything go into 5 and 12? So we can't. Now, 6 and 12, they're numbers that go into both, but why are we not allowed to reduce them? Because this has a radical and this one does not. So this is your final answer. So you guys handle 30 on your own? No? Shall we do it? What do we multiply top? Okay. Is there anything to reduce? Because there's two radicals, that's the only thing I'm allowed to reduce. Does anything reduce? No. Kids will say, oh, the two 2's, but one's a radical, one is not. What do we multiply top and bottom by? Again, why? Because we want the denominators to have a pair. Okay, 2 stays 2. Root, these two are both in radicals, so what do I get? Root 14 over what? 2. Root 2 times root 2 is 2. Can I reduce the 2 with the 14 or the 2 with the 2? Right, I can't reduce the 2 and 14 because one's a radical, one's not. 2 becomes 1, 2 becomes 1. What am I left with? And is root 14 okay as long as it's not in the denominator? Do a quick mental check, or even on your paper, what does 14 break down into? Any pairs? No. So root 14 is your final answer. Yes. You tell me, what would you multiply top and bottom by? Root 5 is correct. What would that give you in the numerator? What would that give you if you multiply the top and bottom by root 5? What would that give you in the numerator, the top of your fraction? I didn't hear you. Can you repeat it? But you're doing root 5 times 3. So what is, because we're multiplying the top and bottom of this fraction by the root 5. So 3 root 5 is correct. And what do you have in the denominator? 5. Does anything reduce? No, it's correct. So you got them all out of me after all. All right, questions? No questions?